In our course so far, we've taken a look at some of the benefits of having network-based storage, including high availability. So for example, if we're using VMFS data stores and we're backing that with iSCSI, and then behind that, of course, we have the LUN supporting that, if all of our ESXi hosts have access to that shared storage, then they can do storage vMotion if they need to, and easily migrate the files for a virtual machine from one data store to another. Another option that we've taken a look at and configured is NFS, Network File System. Also network-based storage, and then behind that we have some type of a server that's sharing the NFS file system so that we can use it as a data store. And what I'd like to chat with you about in this nugget is the concept of a virtualized storage area network, or vSAN. And because the storage in network-based storage has to come from somewhere, let's chat about where, with virtual storage area networking in a vSphere environment, that storage actually comes from. So here's the concept with virtual storage area networks, or vSAN. The idea is that we have some ESXi hosts in our cluster, and each of those hosts have some disks. So for example, this is ESXi 1, 2, and 3 respectively. And if we have some disks that are not currently being used on each of those hosts, we could go ahead and have them used by vSphere as a contribution to a virtual storage area network. And we can make a logical data store out of the hard drives collectively made up across our hosts. Now, there are some requirements for this to actually work. In the old days, a version or two ago of vSAN, we'd have to have at least one solid state disk and then traditional drives that had a platter and were spinning. And that was the minimum requirement on each of the ESXi hosts. One solid state drive and one traditional hard drive that could be contributed towards the vSAN. And if we had more of the traditional disks, those could be contributed as well. And the idea is this: the solid state or flash drive, which is really, really fast, is going to be used for caching. And then the actual spindle drives are used for storing the data. Now, that was the old days. And so this combination of solid state drive and then the traditional drives would be placed into a group, and then that group of disks would be used by vSAN. Now, that was the old days. Now, currently, what we can do is we can have all solid state drives. And then we'd specify that one of them is going to be used for the cache, and the other one or ones, depending on how many we have, we could then allocate to store the actual data. So it's mix and match, but at a bare minimum, you need two drives. One has to be solid state, the others can be whatever. Also, ideally, we're going to have 3 hosts or more that are contributing drives towards the vSAN. Now, in order for this to also work, each of the ESXi hosts is going to be receiving and sending data back and forth as they're respectively reading to and writing from these drives that are now part of the virtual storage area network. And to do that, they're going to use IP addresses on the ESXi host, which are associated with VM kernel adapters. And VM kernel adapters are not new to us. We're using one for management, we're using one for vMotion, we're using a couple of them for iSCSI. So ideally, we'd have a separate VM kernel adapter with a separate IP address that's going through a switch, either a standard switch or a distributed switch, with dedicated uplinks, and then having a dedicated network just for vSAN, so there's no bottleneck there. And if we're using all solid state drives as part of our disk groups, we should have at least 10 gigs available for connectivity from the ESXi host to the network that's supporting the vSAN traffic. In our lab topology, what we're going to do is we're going to just double up a little bit. We'll go to the properties of VM kernel adapter number 2, which initially was used just for vMotion. And then as we added fault tolerance in the lab, we used that same VM kernel adapter for fault tolerance logging, for the replication between the primary and the secondary VM running on 2 different hosts. And for lab purposes, we're also going to check the box that enables that same VM kernel adapter to be used as an IP address as it communicates for the purposes of virtual storage area network. And although it's probably an outlier regarding people using IPv6 for communication on their vSAN, vSAN does support IPv4, and if we want to, it also supports IPv6 for moving the data around. And on the network that is supporting the connectivity for the vSAN, as the uplinks are connected to physical switches, those physical switches also need to support multicast, because there are some multicast groups involved in some of the features. So what we get to do in the lab is we're going to implement vSAN, and one of the challenges that we face at the moment is that we have one ESXi host in cluster 1, and we have 2 ESXi hosts in cluster 2. So we're going to have to do a little bit of rearranging to put them all back in the same cluster. And have no fear, I'll walk you through each and every step in the hands-on lab right now. So for this lab, we've logged on as administrator at nuggetlab.com in the hands-on lab. And the first challenge that we need to address is that we only have 2 hosts in cluster 2 and 1 host in cluster 1, and it's ideal to have at least 3 hosts in working with the vSAN. So we're going to do a little bit of cleanup. So if we click on cluster 2 and we click on the summary tab here, one of the things that I noticed is that we currently have VM5 that's enabled for fault tolerance. And there's nothing wrong with the fault tolerance. It's wonderful. We did a whole lab on it. However, if we attempt to move these ESXi hosts out of this cluster and put them into cluster 1, it will not let us do it if we have this VM still identified as needing fault tolerance. So what we'll do is we'll right-click on VM5. And then for the Actions menu for VM5, we'll hover over fault tolerance and we'll turn off fault tolerance for VM5. It's asking if we want to turn off fault tolerance. I believe we do. We'll click on yes, and the icon just represents normal VM, not one that's being protected by fault tolerance. Next, to move these two ESXi hosts, they have to be in maintenance mode for us to move them. So to do that, let's click on cluster 2, and then let's click on the hosts tab over here, and we can do them both at the same time. So with the ESXi2 highlighted, we'll click on that row, and then we'll hold down the shift key, and we'll grab the second one here, which is ESXi3, and with both of them highlighted, we could right click and specify we want to enter maintenance mode, or we could use this icon right here to enter maintenance mode for both those hosts. So we'll click on enter maintenance mode. It's confirming that we want to apply this action to 2 objects, both hosts. We'll click on yes, and now it's confirming that we really want to go into maintenance mode, and we'll click OK. And then we'll click on recent tasks and make sure that that completes before we take the next step. All right, shows us complete. We'll minimize the recent tasks. And then we could drag and drop these bad boys up to cluster 1, or we could just right click on cluster 1, and from the cluster 1 actions menu, we could select this option, move hosts into cluster. So let's click on that, move hosts into cluster. We'll go ahead and put a check in the top box, which puts a check next to ESXi2 and ESXi3, and we'll click on OK. So it looks to me like they made it. So let's click on cluster 1, and we'll click on the host tab, and then let's go ahead and highlight the row for ESXi2, hold down the control key or the shift because they're next to each other, and highlight ESXi3 as well, and then we'll click on the icon for exit maintenance mode. It's going to confirm you want to do this on 2 objects. We'll click on yes. So we have some stuff left over in cluster 2. So we've got a couple of resource pools and we have a VApp, but I see the virtual machines for the VApp that followed the host that they were running on. So if we expand this VApp, it is empty. All right, so there's nothing in either of the resource pools. There's nothing in the VApp. So we can go ahead and delete all of that. If we right click on cluster 2, and then from the menu for cluster 2, click on delete, we can then click yes to confirm, and it deleted the cluster and the resource pools and the empty VApp, and they're all gone. So fantastic. One of the elements that we need to be aware of is that if we have high availability enabled on a cluster, we need to disable that just temporarily long enough to set up the vSAN, and then we can re-enable it. So with cluster 1 selected, let's go ahead and click on configure. And let's just verify whether or not we have high availability enabled on cluster 1. So at the moment, it's indicating here that regarding cluster 1, that high availability is turned off. Fine. So that saves us a click there. Next, we need some additional drives on ESXi 1, 2, and 3. Specifically, we need 2 drives on each one of them. One that looks and feels like it's a solid state drive, like a flash drive, and the other one that could be solid state or it could be a traditional drive. Now, one of the benefits that VMware allows us to do is lie a little bit regarding the disks. We can actually identify a disk on an ESXi host and click a button that tells vSphere, let's pretend that's a flash drive, even though it's not. And that can come in handy in a lab environment where we need to emulate or pretend that there's a solid state drive that's used for caching as part of vSAN. So I added 2 disks to each of our ESXi hosts. And just to make sure that the ESXi host can see those disks, let's right click on the cluster. And then from the actions menu for cluster 1, let's hover over storage and let's go ahead and click on the submenu option of rescan storage. And that's going to have each of our ESXi hosts go out on their adapters and see if there's anything new, which there is. There's 2 new drives on each ESXi host. And there's no new volumes, so we can take that one off. There's also a warning that rescanning all adapters can be a little bit slow. That's okay in the lab environment. We'll go ahead and click on OK. And then we can click on recent tasks and watch each of them scan their adapters. So ESXi 1 is currently scanning. We'll let that finish. Then there will be ESXi 2. There it goes. And when it's done, there'll be ESXi3. And that way they can all be aware of the 2 new hard drives I added to each of the hosts. Fantastic. So we'll minimize recent tasks. And for a moment, if we went to ESXi2 just for grins, and with ESXi2 selected, we clicked on Configure. And then under Storage, we went to Storage Devices. Here are the new drives. There's a 40 gig there, and there's a 40 gig there. And currently, those are 2 drives that are not being used. So if we wanted to pretend that this drive right here was a solid state drive, which at the moment it believes it's a hard disk drive, a traditional one, we could just highlight that row, click on the little F for flash, and it would remark it as a flash drive. So we could do that on each of our ESXi hosts to effectively game the system, to make it believe that it has a solid state drive in each of the hosts. So let's do that. We'll go to ESXi1 first. I'm just going to do them in order. We'll grab that top disk, click on the little F. That marks the selected disk as a flash disk. Click on Yes to continue, and then we'll go to ESXi2 and do the same thing. Under Configure, Storage, Storage Devices, grab that top 40 gigabyte disk, and go ahead and click on the button to make it think it's a flash drive. Click on Yes, and then repeat the same process for ESXi3. Clicking on that top drive, and then telling it that it's a flash drive, and clicking Yes to confirm. So if we go back to ESXi1, now that it's had a few moments to think about that, it's now showing up as a flash drive, aka a solid state drive. And if we wanted to flip it back, there's yet a button again that now says you can turn it back to a hard disk drive if you want. And of course, it's not literally changing the drive, it's just changing the belief system, if you will, of vSphere regarding that drive. So now that each ESXi host has a solid state drive and a traditional drive that are currently not being used, they can both be contributed to the vSAN. So to create the vSAN, we're going to go to the cluster. So we'll click on Cluster 1. And with the Configure tab selected, we have a section for vSAN. So if we click on General under vSAN, currently it indicates that vSAN is turned off. And so if we click on Configure in the upper right hand corner regarding vSAN, we have some options for deduplication and encryption and setting up fault domains. For the purpose of this specific lab, I just want to get it up and running and functioning and then verify it works. So on this first page of the Configure vSAN wizard, I'm going to leave it all at the default and then click on Next. And then, then it's saying, hey, you forgot something. Basically, here's our 3 ESXi hosts, but none of those hosts have any VM kernel adapters that are specifically flagged as enabled for vSAN. So what I'm going to do is punt. I'm going to click on Cancel. And then let's go back to our ESXi host because I just darn forgot to do it. Let's go back to our ESXi host and flag the VM kernel adapter number 2 that we also want to allow vSAN traffic on that VM kernel adapter. So it has an IP address to use to send back and forth the packets regarding the vSAN traffic. So to do that, with ESXi1 selected and with the Configure tab selected, let's go under Networking and let's go down to VM kernel adapters. So we'll click VM kernel adapters. And we've got 4 of them, 1 for management, 2 for iSCSI, and then 1 for vMotion. Let's click on the VMK2, which is being used for vMotion. And currently down here it says the enabled service is vMotion. I was also expecting fault tolerance logging to show up here, but I just realized that we did that in cluster 2. So ESXi2 and ESXi3 had that enabled, but ESXi1 wasn't part of that. So let's go ahead and edit the properties of VMK2 by having it highlighted here and clicking on the Edit Settings icon, the little picture of the pencil. And what we're going to do is we're going to enable vSAN. And while we're here, if we do want to enable fault tolerance and have ESXi1 also be able to provide that service, I'm also going to enable that here by checking the fault tolerance logging checkbox, also for that same VM kernel adapter. And with those in place, we'll click on OK. And then let's click on ESXi2 and do the same thing. Under Configure, VM kernel adapters, VMK2, with it selected, we're going to click on Edit, and then click on the checkbox for vSAN and click OK. And we'll repeat the exact same process for ESXi3. Selecting it on the Configure tab, VM kernel adapters, VMK2, clicking on Edit, and allowing vSAN traffic on the VM kernel adapter named VMK2 and its associated IP address. And then we'll click on OK. So here in the properties, for that VM kernel adapter on all 3, it should support vMotion, fault tolerance logging, and vSAN. So with that in place, let's go back to cluster 1. And with cluster 1 selected, on the Configure tab under the General section for vSAN, let's click on Configure. We're going to leave the first page in this wizard at its default and click on Next. This looks a lot better. Now it's indicating that VMK2 on each of these ESXi hosts is enabled to support vSAN traffic. Fantastic. And we'll click on Next. Next, it went out and it looked on each of those ESXi hosts and it identified that, hey, each ESXi host has a 40 gig flash SSD drive and a 40 gig traditional drive. And what we could do is we could contribute those to the vSAN. And if we want to see the details for them, we could expand them. So this is showing us the pseudo SSD drive on each of our ESXi hosts. That's why there's 3 of them here. And if we expanded the hard drive, it's showing us the traditional hard drive on each of the 3 ESXi hosts. So we can collapse that. And if we want to assign that to vSAN, we can go up here to this icon, which is the icon for claiming for cached here. Effectively, these are going to be the cached drives, the SSDs on each of the ESXi hosts. So we'll go ahead and click the little drive with the lightning bolt. And then that shows up here as being claimed for caching. And then we'll click on the traditional drives, which is row 2, and we'll click on the icon that associates these drives to be used for data storage. And also, they give us the option here of changing the disk type. So if we didn't do it individually on each of the hosts and we wanted to pretend that we had a disk that was a solid state drive, we could highlight it here, click on the little F for flash, and it would mark them as a flash drive. So let's click this second row and then click on this icon here to allocate those drives for storage. So we'll click that icon. And down here it says, configuration correct. You got at least 1 solid state drive and 1 traditional drive on each of the ESXi hosts they're going to be chipping in. So from a caching perspective, we're going to have about 120 gig of solid state drives that are used for caching and approximately 120 gigs that can be used for storing VM files or any other type of files that we want to store on this vSAN data store. And then we'll go ahead and click on Next. Here is a summary of what is about to happen, and we'll click on Finish. So it is doing a refresh. While it's doing that, if we click on Recent Tasks, just to verify it's all done, fantastic. And now it shows us that vSAN is currently turned on. Also, now if we wanted to go back to vSphere High Availability and click on that, we could click on Edit, and we could enable HA on the cluster as well. And we'll click on OK. And let's verify DRS is on as well. Fantastic. So on this cluster we have HA, DRS, and vSAN all up and operational. And we have an alert on the cluster. So if we select the cluster and click on Summary, it's going to put that right here. So it's saying you've got some hardware compatibility issues. Very well could be because we're pretending to have solid state drives, which also could contribute to our performance service status. So I'm going to click on Reset to Green for both of those, and we'll see if they come back or not. So if we go over to Storage, let's click on the Storage tab right here. So here we have our data store cluster, we have our local data stores, we have our NFS data store, and then we have our vSAN data store. That's pretty cool. Let's go ahead and verify if it works or not. Let's right click on the data center and let's hover over New Virtual Machine, and then from the submenu click New Virtual Machine. Now I want to tell you something about our environment here, and that's this. We have these ESXi hosts that are all contributing disks over to vSAN. But the reality is about these ESXi hosts is that all of this, every ounce of it, is also being virtualized. And the caching drives that we also contributed as part of vSAN, those are virtualized too. So I guess the point I wanted to mention is that in a production environment with the appropriate hardware on the compatibility list and real solid state drives for caching, it's going to be pretty darn fast. In the lab environment, our vSAN is not going to be Speedy Gonzales. So instead of just migrating a virtual machine that has a multi-gigabyte hard drive over to the vSAN, which might take 10 or more minutes, I just want to create a teeny little VM with a teeny little hard disk. And that way we can have a VM that's using the vSAN data store for its virtual machine files, and it won't take a lot of time for it to copy that information over there. So we'll create a brand new virtual machine. With that selected, we'll click on Next. We'll name this Small VM. We'll go ahead and put that in the VMs folder, click on Next, and we'll just drop this in cluster 1. DRS will automatically place that on an ESXi host for us. Click Next. For the storage, let's go ahead and choose vSAN Data Store. And with vSAN Data Store selected, we'll click Next. And then we'll use the latest and greatest hardware version for this VM and click Next. And now it's asking us what type of operating system is this going to be. Let's say it's going to be a Linux device. And let's also scroll down and specify it's going to be an Ubuntu 32-bit machine and click Next. That way it's going to give us initial recommendations regarding processor and memory and disk. And for the hard disk, I'm going to crank this bad boy down to 2 gigabytes. So I'm not going to bother installing the operating system on that 2 gigabyte hard drive. I just want the hard disk not to be huge. And regarding that hard drive, let's expand the hard drive section. And let's make sure it's set for thin provisioning, so it'll even be less than 2 gigs until we start putting some data on there. So let's go ahead and click on Next and Finish. And then we'll go ahead and click on Recent Tasks and allow that to complete. Wow, that was pretty fast. So it says it's done. Let's go ahead and minimize Recent Tasks. And let's click on the vSAN data store here from the storage view. And with that vSAN data store selected, let's click on Files, the Files tab for that data store. And this data store is being supported by all those disks from ESXi 1, 2, and 3 that they contributed towards the vSAN. So there is our folder for the small VM if we click on that. And here are our files. So we have 36 megabytes tied up right now for the hard drive. And if we went to install an operating system on that VM, because it's thin provisioned, that would continue to grow as far as actual disk space being used as we put more and more data on that virtual hard drive. So here, our intention was just to verify that the vSAN data store was functional and accessible, and it worked to store files for a VM. So now, my friend, it's your opportunity to do the hands-on practice in not only the rearranging of our vSphere by moving a couple of hosts out of their original cluster and putting them in cluster 1, but also walking through the configuration for the basic implementation of virtual storage area networking. And as I say that, we have some warnings regarding host memory usage. So if we click on each of these ESXi hosts and click on the Summary tab, ESXi 1 is complaining about no redundancy for the network. ESXi 2 is complaining about the same. And ESXi 3 is also complaining about redundancy. So I can understand the memory utilization on ESXi 1 because it is supporting the vCenter Server appliance. And if we look at the memory utilization, it's getting up there. While we're here, let's check out the networking, because I thought we had redundancy on the management network. We can verify it. We'll click on ESXi 2. We'll click on the Configure tab for ESXi 2. Under Networking, we'll click on Virtual Switches, and then we'll bring this down a little bit so we can see it. And vSwitch 0 is where our original VM kernel port is, VMK0, with the management IP address, and it's got 2 uplinks. We're doing NIC teaming out to the external network. So what we could do is go to Monitor, and under Issues, we can click on All Issues, and we could right-click and simply say Suppress Warning. And then we'll click Yes. So we do have redundancy in place for our management network, but I'll tell you what we don't have redundancy for, and that is our VMK2 adapter, which is this guy right here that we're using for vMotion. It's associated with switch 3, and if we look at the virtual switches and click on virtual switch 3, we don't have any redundancy there. And we're going to have to live with that because I'm out of VMNICs. But if we click on Alarms, the only alarm we have left is ESXi 1. I'm going to right-click and reset that to green. That one's going to be back, though, because if we click on ESXi 1 and click on Summary, that bad boy is just about out of memory. It's got 15 gigs used out of 16 gig total. And the only VM that we have running on ESXi 1 is the VMware vCenter Server appliance. And the reason that ESXi 1 is now using a little bit more memory than it was previously is because it does take some overhead to support vSAN, and that overhead is going to be felt across the board on ESXi 1, 2, and 3. And ESXi 1, because he's already loaded up with the vCenter Server appliance, is now feeling the pain, and it's very likely that alarm on ESXi 1 is going to come up again and again as it's using most of its physical memory on that host. So we may have to just live with that. So have some fun in the lab setting up vSAN, and I'll see you, my friend, in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.